Hey everyone, today's lesson is over combining like terms to solve an equation. This is your title of the video and you should put it in your notes, or title of your notes. I will be working with about 6 equations. This should fit on one page. If not, it is okay. You can continue on the next page. That is definitely up to you. You will follow along with me. So when I have the equations written on the board, just go one by one, write the equation and then solve it in your journal. Then pause the video to rewrite the next equation and then solve that in your journal. The reason is it's going to help you save space for the work underneath the equation. So make sure that you're not just writing a bunch of the equations down and then have no space to work and just show the steps, okay? Because we're going to be making sure that we show all our steps to us solving equations. Okay, so like terms, the key words here, like terms, we're going to be putting them together, combining them only if they are alike. They only go together if they're alike in equations. So we got to figure out what the alike terms are. Just so we see, like terms are stuff that looks alike. For instance, this 4x right here is a like term with this 6x right here. Okay, notice I do include the sign in front of the number because that is going to help me to know that this is a positive 6 value and not a negative 6, like if it were subtracting. This right here is a positive 4. Even though there's nothing here, that's how I know it's a positive 4, just so we know. So these are like terms. We're going to be able to combine them, to put them together. As in, I had 4 x's written way up here in the top. 1, 2, 3, 4, 5. 1, 2, 3, 4. And then 6 more x's. 1, 2, 3, 4, 5, 6. If I totaled these x's, I would have 10 x's all in one place. That is why we combine like terms, to make it a little bit easier for us to understand what's going on. And as a little side note here, the x's are not the only ones that are like terms. Technically, the constants, remember constants are numbers with no variables, are also like terms. However, these like terms are not going to be able to be combined really easily for this reason. They are on opposite sides of the equal sign. They are on 2 different sides. They cannot just go sit together and be friends really easily. It's going to take some work. These 2 could go together nice and easy because it's just a simple math problem. It is 4 plus 6 equals 10. This one says 3 equals 33. Whoa, whoa, whoa. So it's a little bit different whenever it's on 2 different sides of the equation, okay? Here's how we do it, and I'm gonna say something that you might understand and you might remember. We're gonna use the inverse property. Inverse property tells us to do the opposite of whatever we're working with. So if I wanted this 3 to go sit with, or to go be with this 33 on this side of the equation, I am going to do the inverse property by subtracting 3 from both sides. Remember, whatever you do to one side, you have to do to the other. So that cancels out here, and I now have 30. So my new equation is this thing right here, this 10x. I'm going to rewrite it so I can see it a lot easier. I now have 10x equals 30. I am still going to use my inverse properties to try to get x all the way by itself. I am isolating the x. I am isolating the variable. That means I'm getting it all alone. In order to do that, I take away this 10 from both sides and I move it over here. Just like normal, divide by 10 on both sides. Remember, this is a division problem. Even though it looks like a fraction, we're technically reducing our fraction. 30 divided by 10 is 3, so x equaled 3 on that equation. All right, let's talk about this one. This one has almost the same numbers for this reason. Over here, we said that 4x and 6x were like terms. They are. However, we're not going to create 10x like we did over here. The reason we do not get to create 10x is because they are now on opposite sides of the equal sign. In order to get them on the same side, I'm going to have to do the inverse property. Okay, inverse property happens anytime you have to jump from one side of that line that you draw, one side of that equation to the other. That's kind of why we draw the line, is to help us stay organized, okay? So what happens is I'm going to move this 4x over here to be with this 6x by subtracting 4x from both sides. Now you might think, how do you subtract x's? This is how. If I had 6 x's, 1, 2, 3, 4, 5, 6, and I take away 4 of them, I am now going to erase 4 of them. How many do I have left? 2 x's. So over here, I am left with just 2x equals, and then the only thing that is not canceled out is this 24. So like that. You might notice that the x is on the other side of the equal sign instead of being on the first side like normal. It's okay, it means the same thing, all right? I will say this really quick. The reason I did not subtract x from both sides is because I would have crossed it out here and then had nothing left to write on this side of the equation. I still have to have something to work with. So I knew I needed to move this 4 over here. That way I can still have things over here and have things over here to work with, all right? The last but not least is to take this 2 away from this x. Right now it is multiplying, so I will divide by 2 on both sides. I get x equals, and then 24 divided by 2 is 12. 12 is x. X is 12. That's it. There we go. Here are 2 more examples for us to practice combining like terms to solve equations. Okay, these are the last 2 examples. So you can go ahead and write them, even if you write, you can just save your space underneath your equations. So pause the video, write them down, because there you go. All right, so I start by drawing my line in between or down the equal sign. That way I can kind of keep things organized, remember, like I said. Next step is to look for like terms. Always look for like terms. I box the letters and circle the numbers. So here is a variable, a number with a variable. Here's another number with a variable. These are like terms. It is important that both of these are y. Remember, the variables can be any letter they want to be, so this time they just so happen to be y. I did box the negative with the 4 because the minus sign with the 4, because now if I look at this as a single, like an individual piece, it becomes a negative 4y, all right? So I'm gonna try to put these together. Now, the nice thing about this equation is I can move the 3y to this side, or I can move the negative 4 to this side. The reason I can do either or is because whether I move this one or this one, there's still going to be something on either side of the equal sign. You just don't want to ever move something and then let nothing be on one side of the equal sign, because then you won't have anything to work with, okay? So let's take this negative 4y and move it over here. Now I'm going to, the only opposite of negative 4 to make it go away would be add 4. I can add 4y to both sides, like that. Add 4y. Just a heads up, if I were to have subtracted the 3y, I would have negative 4 minus 3, which is doable, but if you just choose not to work with negatives, sometimes that's the reason you pick certain numbers to move first. So now I'm not working with negatives anymore. I have 3 plus 4 is 7y. I do have this minus 8 on this side of the equation still, so I just rewrite it. We did nothing with that number just yet. Over here, I did nothing with the 13, and that went away, right? I don't have to put plus 0x because that means nothing. That means that there are no x's, and so we don't write that. All right, so let's go ahead and continue working with like terms. I want you to remember that this did look like a 2-step equation to begin with, but I now want you to get in the rhythm of thinking that these are like terms. These constants are like terms. We need to put them together using inverse property. I am going to move the 8 to this side and not the 13 to the other side because I still want things to be on both sides. So add 8 to both sides. I am left with 7y over here and 21 on that side. 13 plus 8 is 21. Last but not least, divide by 7 on both sides. You get y equals 21. And that's your answer. All right, let's move to the next equation. Oh, wow. It's not a straight line. I'm not going to take the time to erase that. Okay. I am boxing all of my like terms, every single one, because this is where it gets tricky. There are many like terms. There's some that are on the same side of each other and some that are on the opposite side of the equation. You have to do the ones that are on the same side first, okay? So 4x and minus 3x are on the same side. This becomes just a simple math problem. 4 minus 3. What is 4 minus 3? It's 1. So I write 1x. This is how I write 1x. Does everybody agree? Yes. Okay. This -2 here we did nothing with, so I'm going to drop it down as a -2. If I would have put -2 and then x plus x on this, like I would have switched them, I would have been just fine. It's very important though that you keep the negative with the 2 and this x would have been positive, so plus, okay? If they were in the opposite, it's okay. Okay, so this is on this side. I made these two combine down into 1, see? It is 1x. If it helps you to draw that 1 in front of the x, go ahead and draw it. I don't draw it because that is the normal way you see variables written. All right, over here we did nothing with it. I'm going to rewrite this side of the equation. Okay, now I still have stuff with my equation. So I'm going to box my like terms, and then I'm going to go ahead and circle. Well, I could circle those. I'll do it later. Let's work with the x's first. I could move this 6x over here, or I could move the x over here, either one. You can kind of choose whether or not what you want to work with first. I'm going to take this 6x and move it over here just because. All right, so 6x minus 6x, and the reason I subtract it is because 6 minus 6 is 0. That's the only way it would cancel out. So I'm going to say subtract 6x from this side. Remember, this is 1x. 1 minus 6. If you type it in your calculator, 1 minus 6, you get a -5. All right, this is a -5x. If you would have typed this in your calculator, 1 minus -6, you would have got the wrong answer. Did you hear the words that I said? 1 minus -6. That's two subtraction signs, two negatives sitting next to each other. Those make a positive number. That makes addition. Don't do that. If you have 1 minus 6, that's all you type, okay? I'm going to drop this down, say -2 and 10 over there because this goes away. Here are my like terms. So I'm going to add 2 to both sides. I get, that goes away, -5x equals 10 plus 2 is 12. The last step, I divide by this -5, or make sure that you are dividing by that -5 right there, okay? 12 divided by -5 does not reduce nice and evenly. It doesn't divide nice and easily. It doesn't even reduce. So that is technically our answer. Our answer is x equals -12 over 5. This -5 down here makes the entire fraction negative, okay? If there were 2 negatives, it would have made the fraction positive. But just 1 negative, no matter where it's at, makes the fraction negative. All right, that is our video for... This is a quick example of how to write an equation using algebra tiles. These are algebra tiles. They represent x squared, regular x, and constant numbers. So the x squareds we do not use in equations just yet because we only work with x's that are not squared, as in squared would have a 2 in exponent. So I'm going to put those to the side. You will notice that these little bars are green on one side, red on the other. Green means positive, red means negative. So if I have 4 x's, I am going to put 4 x's of my algebra tiles like that. And then if I have -3, I'm going to take these little red and yellow squares, and I'm going to use 3 red side of the squares. The red side stands for negative. So now that I have a -2x on the other side of the equal sign, I'm going to put 2 of the bars. These are the x's, and they're on the red side, so they show negative. Sometimes if you have a test question where it does this, it does shading and not shading. Shading would be negative, not shading would be positive. And so now that this says 3, I take 3 of these little squares and I flip them to the yellow side. And there I have done an equation with algebra tiles.